Hi, everyone. Welcome to our very first installment of our How It's Made series. This series was conceived by Laura Karnath and was made to explore how building materials and products are manufactured, the main sources of embodied carbon in that manufacturing process, and what is being done to reduce the embodied carbon. So today we are going to cover facades. And we are joined by the four speakers that you see up on your screen right now who will walk us through the manufacturing process for stone wool insulation, glass, and curtain wall systems. So I'm going to run through a quick background of all of our speakers right now, and then we will go ahead and get started. So first is Alejandra Nieto, joining us from ROCKWOOL, where she is the sustainability manager. She manages this profile of ROCKWOOL products through certifications and listings and works with industry leaders to drive the use of low carbon sustainable products. She's an active member in ASHRAE technical committees, including the chair for TC 4.4 building materials and building envelope performance, teaching part-time at George Brown College in Ontario, and currently sits on the California Building Standards Commission Green Building Code Advisory Committee. And she is also a certified passive house consultant. Joining her for ROCKWOOL will be Todd Kimmel, who is the U.S. Senior Manager of Sustainable Solutions and the co-founder and chairperson of the Rainscreen Association in North America. Todd has over 20 years of leadership experience working on building enclosures and facade systems. He was part of the working group to develop the AMA 509 testing standard for drained and back ventilated Rainscreen. He is a construction documents technician, a certified passive house designer, and currently sits on the board of directors for New York Passive House. Next up, we'll have Kris La-Borde joining us from Guardian Glass, where he is the regional technical advisor. He has more than 16 years of experience. He was previously a facade engineer for Thornton Tomasetti in Los Angeles and in London. And prior to that, La-Borde spent 4 years with the Swiss facade contractor Yuanda, where he engineered facade systems and specialized in curtain wall for commercial developments across mainland Europe and the UK. And then lastly, we will have Andrea Zani, who was the former R&D Innovation Manager and Sustainability Lead at Permasteelisa Group, where he managed and led the development and delivery of innovative, low-carbon, and high-performance facades. He shaped and drove Permasteelisa Group's decarbonization strategies to achieve carbon neutrality by 2040. He is a member and co-chair of the Society of Facade Engineering North America Hub and is active in facade tectonics advocacy and as a member of its embodied carbon working group. So with that, throughout the presentation, please feel free to drop your questions in the chat, and there will also be an opportunity for Q&A at the end. We are hoping to leave about 15 minutes for that. Now we'll begin with our first topic and speaker, the stone wool insulation by Alejandra and Todd.
Thank you, everybody, for joining us, and thank you to the LACLF for inviting us to be part of this program. I think it's the first time I've been part of like this kind of behind the scenes look at full facades. And exciting to be with Kris and Andrea on this program. So just representing ROCKWOOL here. Many of you may be familiar with us. I don't know, but we're certainly going to get you familiar here in a second. And Aria, thanks again for the introduction. So we're, Alejandra and I are both part of ROCKWOOL North America. Alejandra really manages our sustainability portfolio from a product and a production perspective. And then my role is more on the business development and kind of front end side of consulting and supporting design professionals, construction professionals on the sustainable applications of our products. So knowing the materiality is really critical as well. But that's just kind of the differentiator here. So we're kind of tag teaming this. I'm just going to start with a little bit of an overview, and then I'll let Alejandra run into the specifics. All right. And so just to familiarize everybody with who we are. So ROCKWOOL Building Insulation is who we're representing here today. ROCKWOOL is a global company that has various divisions. Alejandra and I really represent the commercial and residential building insulation segment of that program, but we do have different sister companies. Just for perspective, we use the same technology that we're going to talk about today for acoustic ceiling tiles through our partner company Rockfon. We also have a big footprint in the growing mediums in the horticulture and hydroponics industry with our sister company Grodan. They use a hydrophilic binder in those products as opposed to what we'll discuss here with hydrophobic binders for building use. So that's a big distinguisher. And then we have a couple of companies as well. Rock Panel actually makes a facade cladding using the stone wool technology that we'll talk about Currently not available in North America, but it is a fairly popular brand globally. And then Lapinus actually uses the fibers that we produce for all sorts of engineered solutions, including brake pads, and we're pretty ubiquitous across the world in lots of unique applications for noise and vibration control and different types of suppressions in various systems. But you can see here that at the core of what we are a stone. We are basalt rock, and it's it's a very abundant resource, and we'll get into kind of some of the circularity elements of that and kind of using this as a natural resource moving forward. Just quickly on who we are historically, we are over 85 years old. We are at our kind of core a Danish company. That's where we started back in the 1930s. I won't go into this full time frame, but I think what's important here are some distinguishing notes of kind of discovering and kind of really starting to promote some of the circularity with our product as far back as the 1970s. So from a sustainability perspective, that's a big deal for us on a global level. We started production in North America in the late 1980s in Canada. So we've had our footprint here since the late 80s, and we've kind of excelled now to a number of factories. And we've actually, from a sustainability lens, you can see here in the early 2020s, we really started to kind of promote and move forward with electrification of all of our production facilities moving forward and looking at even existing facilities to move towards electrification. As mentioned, we have a growing presence here, and it's really great to be with the California audience predominantly here, as this is a very key segment for us from a fire resilience perspective and a sustainability perspective. And we're invested in the growth here. We actually just started to kind of break some ground on a new production facility in Eastern Washington State in Walla Walla County, that is. And again, with all of our new facilities, we're moving towards low carbon production, electric cupolas. And this is going to be on the Columbia River using hopefully hydropower to run this facility. So we're very excited about this facility and servicing the West Coast in the not too distant future. And just to highlight as well, just the various strengths of Stonewall and kind of what we like to emphasize with all of the brands and the sister companies, under our label. And what's kind of critical here for this conversation, when it comes to sustainability and carbon, I mean, fire resilience is a big deal. Long-term thermal performance in terms of providing thermal value for the life of the building, in terms of maintaining durability and promoting durability for the buildings that we're involved in, not just from a fire perspective, but from just a general perspective of environmental impacts. And then circularity. These are products that can be reused and recycled back into the production facility, which we'll talk a little bit. And I think those are the big ones that we want to talk about here today. But there's a lot of strengths and values with Stonewall. I do mention Stonewall specifically, and just to demystify things, because there's a lot of terminology here, and I'm sure everybody on the call is familiar with the term mineral wool or mineral fiber and fiberglass. So we're going to be talking about Stonewall because that's what ROCKWOOL produces. Mineral fiber is the overarching category that includes any of these fibrous inorganic substances. Fiberglass being one of them, which we're all familiar with, low density, glass fiber insulation, usually used for interior applications in buildings. And then you have mineral wools, and mineral wool is a combination predominantly of stone as a prime ingredient and slag being the byproduct of iron ore in the steel production process, and oftentimes makes up the recycled content in a mineral wool. So if you have a higher stone content, you're considered a stone wool. If you have a higher slag content, you'd be considered a slag wool. Both are mineral wools. So ROCKWOOL produces predominantly a stone wool type product, and we'll talk about that as well. Refractory ceramic fibers, there's another fibrous mineral fiber, I should say, which is used really for industrial applications. So it's probably something that most people on this call don't interface with, but it is part of the mineral fiber segment. But it is important, as anyone out there working with these products and maybe specifying these products, to distinguish. If you want a mineral wool, you should specify mineral wool, not mineral fiber, because if you specify mineral fiber, you might get fiberglass, which might not be what you want. And we're going to show a video at the end of this deck because we just want to make sure that it runs properly. And that's going to get into the full manufacturing process. But just quickly, when we talk about manufacturing stone wool, again, we're taking that basalt rock, we're heating it to high temperatures to the point of melting, And then that melt is spun into fibers. So it's not too different from making cotton candy, but instead of melting sugar into and then cooling it into fibers, we're melting rock. And then those fibers can be collected in either to low density bats for interior applications or to high density boards, which can be used in exterior applications or other kind of high compressive strength requirements. And so with that, there's a lot of versatility. And so, for those of you on the call, you may be, have interfaced with Stonewool for certain applications, but we cross the spectrum, right? So interior bats for partition walls, all the way to, low slope roofs and exterior rain screens or below grade foundation. We can kind of cross the spectrum based on having this variety of densities, which is great.
So as Todd mentioned, we do have a video that we want to showcase about our production process that we'll get to at the end of the presentation. But just to get into a little bit more of the details of the Stonewool production process, here is a flow chart that kind of covers the different steps in more depth of all the stages of production for Stonewool insulation. So starting on the left, you have what is Stonewool insulation made out of? What are our primary raw materials? So we're thinking about stones, internally recycled wool. We do use different fuels that go into our production process. For our facilities right now in the US, the two main sources of fuels are going to be natural gas and electricity. And then of course we do put some resin that kind of holds together all of our fibers together to actually create the final bats and the final boards. So these raw materials go into a furnace, and our furnace is essentially there to melt all the rocks and create that lava-like material that then gets spun and turned into the natural fibers. So when we think about natural fibers, it goes into the curing process and then eventually to the packaging process before it exits the door to get to our customers. So when we think about the production process, really the hotspots that you're going to see or that we see in the life cycle assessment of our products is with that melting part of melting the stones as part of the production process. As you can imagine, it does take a lot of energy to get to melt stones. We have to get the furnace to a very high melting point to do so. And then in the coming slides, I'll talk to you about our sustainability goals and decarbonization plans and how we're going to essentially lower the emissions associated to this critical part of our production process. The other thing that I wanted to highlight based on this flow chart here is that you'll see along the process, we have the dotted red lines, and that really highlights all the different times and areas within the process where the stone wool can be taken and recycled back into the process as needed. So stone wool can be endlessly recycled. So we can take any product that comes off our line that perhaps doesn't meet, quality specifications, that, any kind of offcuts, trim edges, and that goes back into different areas throughout the process to recycle that, enabling us to have zero waste to landfill within our facilities of that stone wool insulation. It also enables us to really scale up and emphasize the recycling capabilities of stone wool insulation with the market. And I'll get to that as well in the coming slides. When we think about sustainability at ROCKWOOL, the UN Sustainable Development Goals is really the platform from which we look at our processes, our impacts from a upstream and downstream, and they really form the core of our sustainability commitments and how we track and measure them. Here's just a quick kind of infographic of how we look at our own operations, but also look at our impacts upstream and downstream and how we've identified the material topics within all of these processes, all of these different stages that we've used to then develop our sustainability goals and commitments. As you can see here, of course, with any manufacturing process, you're going to have an impact to the environment in terms of greenhouse gas emissions that occurred during the production process. One of the beautiful things about stone wool insulation is that there's a lot of also handprint benefits that also comes with the use of stone wool insulation. In that insulation, when it comes to building energy efficiency, is one of the only products that has a positive contribution to the energy efficiency of buildings. It has a positive contribution to the fire resiliency and the durability of our building enclosures. And so all of these different aspects, both the handprints and the footprints of our production process, are measured. From the UN sustainability goals, we have 6 Sustainable Development Goal related sustainability goals. And then we have 2 science-based targets. So our SDG related goals encompass reduction of scope 1 and scope 2 carbon emissions intensity for all of our facilities globally. We also have goals to reduce the water use intensity at our facilities, and a goal to reduce our waste to landfill from our production processes. Other goals that we have include improving the energy efficiency of our own buildings. So actually actioning on what we're promoting in the industry of making buildings more energy efficient. And so we have a goal to ensure that all of our owned and used buildings are meeting high performance building standards. And then lastly, we have our goal to enhance the circularity component of our products and increase the offering of our recycling service through our ROCKWOOL program. So these goals were developed back in 2015, and most of them have a timeline to 2030. In 2019, we took a step further and we got science-based targets approved. And these 2 science-based targets are specific to the first one being an absolute reduction of scope 1 and scope 2 greenhouse gas emissions and an absolute reduction of scope 3 greenhouse gas emissions. And so the key differentiator here between these SBTI targets and our original decarbonization sustainability goal is that with an absolute reduction goal, business as usual is not going to get you to achieve these goals. We really have to dig deep and really understand what are the hotspots within our production process. How can we actively and proactively innovate and improve the efficiency of these production processes to reach these true decarbonization goals, which leads us to our latest goal, which is to achieve net zero greenhouse gas emissions by 2050. And just to sum it all up, all of this is very critical and important to our decarbonization strategy. But at the cornerstone of our business is ensuring occupational safety and health of our employees. And so this is also at the foundation of everything that we do on a day-to-day basis. Here's a bit of a more in-depth look at the CO2 emissions related goals that I highlighted in the previous slide. And I highlight these specifically because, as I mentioned when we were looking through the flow diagram, that the furnace and the melting piece of the production process is what generates the most greenhouse gas emissions and carbon emissions throughout our process. And so these goals are specifically developed to tackle those emissions in order for us to really achieve a truly holistically sustainable product. And so here you can see more closely where we are in terms of meeting those targets. So our original SDG goal, we are actually ahead of the target, already surpassing the 20% reduction by 2030. And we have some strong progress within our SBTI goals as well. But how are we actually achieving this decarbonization in our production process? And so our targets really sit on 3 pillars of initiatives and tactics that we're implementing across the globe and here in North America. So the first one, as I mentioned a couple of times, is energy efficiency. So energy efficiency of our own buildings, but optimizing the energy efficiency of our production factories as well. And this primarily includes and tied into the second pillar of technology innovation of improving and transitioning our production processes, which are historically from either coke and coal. We've already done the first transition of now converting that into natural gas as the primary fuel source. And what's next on our decarbonization path is electrifying our processes. And we have some very successful examples throughout the globe of either a new facility or facilities that are transitioning to this new technology. And as Todd mentioned, within our growing presence here in North America, our newest facility, which is being built on the West Coast, will be using electric melting technology. In fact, it'll be the largest electric melter for ROCKWOOL throughout the globe. And all of this really stems in our commitment to innovate and the technology of producing stone wool insulation. As you can imagine, it's not an easy feat to electrify these processes. And so we are very proud of the work and the innovation that we are making within this industry. And lastly, we have circularity. Because our products can be endlessly recycled, we really want to emphasize the fact that this product can contribute positively to a circular economy, that it can be considered a closed loop product. And so we're really focused on how do we limit not just our landfill of stone wool insulation, but also in the market. So we have this Rock Cycle program in North America right now. It's in its pilot phase. It's really at its infancy, and we're really focused on some select customers. You know, there's lots of logistical challenges, lots of distances to cover. And so what we're really focusing on is building that framework so that when buildings get to their end of life here in North America, they're being deconstructed and that they've used stone wool insulation. Originally, they have a recycling stream to use so that they can divert it from landfill. I think most of us on the call right now are very familiar with the different life cycle stages of embodied carbon. And so everything that I talked about within the sustainability goals and our SBTi decarbonization targets is really meant to also then impact the life cycle and the embodied carbon of our products. And then here just highlighting some of the key aspects and key embodied carbon impact areas of the production. So happy to talk about this more in depth. If you have any questions, please do reach out to us. And maybe if we have time at the very end of the discussion, we can talk about, we can play the video. So
yeah. We can also put a link to the video in the chat if it's publicly available. And I know I saw some great questions already asked in the chat that we can hopefully get in the next Q&A.
Yeah.
But I think we should
It is
Yeah,
good
start the
to
next
note that we do have
presentation.
a type 3 product specific EPD. So if people want that, we can also put that in the chat.
Yeah, so we will definitely, I'll go through the questions and try to answer as many as possible. So thank you for your time and look forward to connecting.
Awesome. Yeah, thank you, Alejandra and Todd. Next up is going to be Kris La-Borde.
So my name is Kris La-Borde. I am from Guardian Glass. But another couple of important people that you should be aware of after this call are people in our technical team and our stewardship team, namely Kate Korowski and Andrea Santa Cruz. They are our stewardship leads. So if there's any kind of follow-up questions on processes and efforts that go on in any of our facilities, documentation from a EPD, lead certification, anything like that, those are the people to speak to. We also have Raymond Roy, who is another one of our technical advisors that covers Northern America. And Heidi Trudell, who I think is on the call too, she is a fantastic fantastic resource. She's kind of spearheading our technical powers on everything bird friendly. So Heidi is everything about birds. I don't think she minds me saying that. And we'll touch maybe on a couple of bird products that we have going on at the moment. So this is really going to be flying through for kind of a quick 101 on how glass is made, but touching on some of our stewardship efforts as well, and some examples, a couple of case studies. Right, well, here's some faces to the names that I just mentioned. Kate and Andrea from our stewardship team, myself, Raymond, and Heidi from our technical team. So, you know, we'll put all our contact details in the show notes at the end, and you can contact any one of us for any kind of technical related questions. But yeah, this is a nice little anniversary for me. So I'm based in LA. We're spread around the world, obviously Guardian being a global float glass manufacturer. But when I first moved to LA, this was kind of what I saw from our office window, was the Wiltshire Grand being built up. So nice little transition into my old life of being in a curtain wall contractor to seeing curtain wall going up on the Wiltshire Grand in downtown LA. And I think it still holds the record for the tallest building on west of the Mississippi, I think. And I've seen a lot of changes going on the West Coast too. I've seen the role of facade engineers and waterproofing consultants change, and the kind of trend I see is we kind of now do a bit of everything, which is kind of full circle. We used to just do vertical surfaces and there'd be a separate waterproofing consultant, and now we're seeing building envelope consultants, enclosure consultants. So there really is a push on projects hiring people or entities that really cover the entire building envelope, and that's really good news for trade interfaces. It's really good news for spotting weak points in the building envelope to give us a more watertight and kind of better performing building envelope. And we're always being pushed more and more that our building skin no longer is just keeping air and water out, but it's actually making the building perform. And when you look at some of the complexities that we have to deal with, glass just being one part of it, you can understand why all these trade interfaces can cause headaches. And we're also seeing the evolution of the facade, right? What it's kind of started off in life to do, tell you what's inside the building. Is it a temple? Is it a place of religion? Is it showcasing what people are doing? And now we're getting really into the high end of facade building materials. Again, glass being just one part of it. So a little bit of Glass 101. Guardian, global company, but here in the USA, we have 6 facilities, float glass facilities, and we also have certified fabricators. It's probably easier to tell you what Guardian doesn't do is what we do. So we are a float glass manufacturer. We make the raw glass, and it may or may not have a Guardian coating on it. Our people who buy our glass are fabricators. They're the ones who buy our coated glass. They'll trim it, edge finish it, cut it, and build it into a IGU or laminate it, and then they'll put it into a framing, which is when the glazers come in to buy. So we're kind of really at the bottom of the stream, and people buy our products. So any glass commercial storefront, window wall, curtain wall, it's at least got 3 or 4 players who have a say in how that product is fabricated, manufactured, installed, and maintained. But we are just manufacturers of the raw glass. What is glass? Well, it's about 50% silica sand, and it's got a little bit of dolomite and soda ash. And this last little bit, about 15+% is cullet, and we'll maybe touch on cullet a little bit later. Cullet is really important because it brings down the melting temperature of all those raw materials prior, and it's also part of the life cycle of products. So the challenge in the glass industry traditionally has been, even though the glass might be reusable, the low-E coating may not have been that friendly. That is no longer the case. Most companies, including Guardian, low-E coatings can be fully recycled as part of that cullet batch, and it can be in-house glass that didn't make it to the end of the line. It's broken up and recirculated into the kiln, or it can be post-consumer. They have to follow strict procedures, but post-consumer cullet percentage is growing and growing and growing. It's probably estimated that for every 10% cullet you use in a batch, you lower your energy demands by about 3%. So it's very, very important. Substrates, a couple of flavors: clear, tinted, low iron. Not extensive, but clear is basically removing some of that iron oxide from the glass to get that less of a green tint. And we invite anyone to come up to one of our facilities. Kingsburg is your closest plant in California. Carlton is kind of my favorite because attached to the side of it, we have our STC center where all our kind of research and R&D and kind of mock-ups get going on. You get to see cool things. So if anyone on this call or their company is interested in coming out to see us, we love it. We always learn something. This is a very quick video. I'm not going to play it all. I'm not going to play the sound, but this is a quick 101 on how glass is made. I know we only have 10 minutes and I'm probably halfway through that. But it kind of flies through the float line process. So this entire line is probably 3 football fields long. We start off at about 3,000 degrees Fahrenheit, melting all the raw materials. And this is kind of where the float glass industry gets its name from. The glass kind of lays on a bed of molten tin. And this is kind of where we let nature and physics help us out a little bit. If anyone specifies glass on this call, think about what is the most common thickness of glass that you kind of see out in the real world. And you'll come back with 1/4 of an inch or 6 mil. 6 mil is what that natural density of glass will settle at. So if you let that molten glass settle by itself, it will always settle to 6 millimeters. So that's why there's a very good reason why most of the glass we see out there is 6 mil. If you want thicker or thinner, then you have to do a bit more work, either hold the glass back or speed it up, stretch it out. But 6 mil, there's always a reason for everything, but that is nature and physics and gravity doing a bit of work for us. Then we get into the cutting process, again, all automated. Everything sits on a bed of rollers. You'll probably hear the term roller wave at some point in the glass industry. That's not applicable to this process, but once you start tempering glass, then these rollers, you can start seeing the undulations under certain circumstances. Shipping, again, opportunities there for us to be more efficient and sustainable. We do strategically place our facilities around the country. Our Carlton plant does have a train line running straight to it. The engineering and thought that goes into transporting brittle, fragile glass onto trains is in itself a fascinating area to look into. But most of ours is done by truck and by road. Sputter coatings, again, this is kind of our low E coatings. They are applied to the air side of the glass. They are basically microscopic layers and ingredients to kind of reflect the sun's energy. Silver, I'm not going to play this video because it's a little bit dry, but it's basically done, maybe I can show one second. This is kind of the most interesting bit. So it gets washed, and then this is the important bit. It goes into a vacuum, so we suck out all the air, and we actually statically charge these cathodes. They're almost like printer rollers, and each one of these rollers is a chemical element. And the silver is the workhorse. We'll also have other chemical elements that kind of the antidotes to what we don't want silver to do. So you statically charge all this, and then you fire ions at these charged cathodes, and they will be attracted to the glass surface. So I'll probably let this play for this little clip and then move on. And this is what gives you that uniform, very flat, I think it's a 1/5000th of a millimeter thick layer. We call these stacks, and depending on the type of coating you want, will alter that recipe. You may hear the terms single silver, double silver, triple silver. Triple silver is kind of where we are at the limitations of getting low E coatings to do what we can do. We've kind of squeezed as much as we can out of low E coatings. The next level of kind of solar performance is really moving on to VIG and then a low E coating on the number 4 surface or 1/500ths. We can look at a couple of those performance metrics. So typical IGU, which you'll see here on the West Coast, you'll get a U value of 0.29. As we start moving into triple glazed units, we'll get to 0.12. But when we see the real power in terms of U value and solar heat gain is VIG, you kind of getting a VIG that's giving you 0.06. So it's probably like 4 or 5 times better than a standard double pane IGU. So VIG, maybe not on the West Coast anytime soon, but definitely when on the East Coast, we're seeing stretch codes, Massachusetts being a particular example. People are starting to have to make the choice between either triple glazing, double glazing with a low E on the number 4 surface, and VIG might be an option now. In terms of other products that we see rising to the top of the list, in terms of trends, bird friendly is huge. It's gone from voluntary codes to we're seeing it in municipality codes and lead requirements. And Guardian has a great range and great resources if you have any projects that you need bird friendly assistance on. And Heidi is listening in, I know. We can have 3 flavors of bird-friendly options, UV, etch, and frit. But again, you're going to see a lot more options for fabrication from our certified fabricators, including heat strengthening, tempering, insulating, whatever the project needs. A couple of case studies on kind of how we can be better citizens and of the world is, you know, we're a manufacturer. We have at every stage of manufacturing, we have an opportunity to be more efficient and conscious of what we're putting out into the atmosphere. Recycling our products is one, transportation is a big one, but fuel efficiency is probably our biggest, and what we release into the atmosphere and what greenhouse gases we can cut down on. We basically melt rock to make our glass. And on one specific case study is our Luxembourg plant. We actually had 2 plants in Luxembourg. And just in terms of location, you probably couldn't get more central to Europe than Luxembourg. So being very strategic in where we place our facilities is an easy one. But Luxembourg actually had a huge retrofit last year. You generally can't turn off our facilities. They get turned off maybe once every 10, 15 years. They're running continuously 365 days a year. But when you do get the opportunity to turn it off, it's your one opportunity to get in there, clean it up, install new equipment, modify kind of fuel sources. So Luxembourg just did this last year, and I went out there while it was shut down. It was kind of weird to see it all empty and being cleaned up. They did a couple of cool things. One is they kind of converted to 100% natural gas. In a couple of our facilities, they are experimenting with using green hydrogen. They also installed about 11,000 PV panels on their roof. The numbers coming back to us saying, hey, that's covering at least 10 to 12% of their energy consumption. Specific to plants here, we're being more conscious about peak energy demands, particularly during periods of inactivity in our plants, being more conscious about how we pull in energy during peak demands. And then our stewardship team will be able to provide you with all our documentation on EPDs, HPDs, safety data sheets, anything you need for project support. Please go to our website. It's all there. It's all public. But pick up the phone as well if you ever need to speak with us. And I am probably close to my time, but here is our Carlton facility in Michigan. Again, you probably see the raw glass part of it at the thin end, and this is the coating and warehouse at kind of the fatter end. When you fly over, you'll probably see sparkle on the ground, and that's all our recycled cullet about to be put into the kiln. In Europe, they're doing a lot more experimentation with increased cullet ratios, especially with laminates, and even in North America, we've done some experiments about using, 70 to even 100% cullet percent ratios. We have a bunch of performance tools to help you out with any projects, whether it's U values, solar heat gain, our performance calculator. I think even now, well, it gives you embodied carbon numbers just for the glass. But again, a useful metric for you to kind of have and use as a reference against other buildups. Sizing, yield, losses in glass. This is a big thing for our fabricators. We have super jumbo glass. Again, we kind of are very conscious about what numbers and widths and heights to do to typical residential and commercial window sizes. We don't want glass rate wastage, but when we do, again, we have the opportunity to go back and do a full life cycle assessment of that coming back into the kiln as cullet. Thank you for having us, and yeah, I'll follow up with any contact information you may need.
Okay, awesome. Thank you so much. That was great. Now we're gonna hop over to Andrea and we'll learn about curtain wall systems.
So thank you so much for having me. I'll jump straight in. So for those that doesn't know Permasteelisa, we are a leading facade specialist and facade contractor across the globe. We engineer, manufacture, install, and maintain curtain wall system across the globe, and we have different branches in the different continents. Here in North America, we have Permasteelisa North America that counts almost 100 designer engineers between Canada and the US. We worked on many iconic projects across the globe. And in the past 50 years since we were found, we install almost 20 million square meters of facades. So hopefully, the company will go on and install other 20 millions in the next 50 years. So there is a lot of embodied carbon, there is a lot of environmental impacts associated with these kind of numbers. So as I said, right, we work on big projects all over across the United States. I hear a few examples of big skyscrapers, massive building like universities. So you see the scale and the complexity of the facades that we install. We are specialized in unitized curtain walls, so that are manufactured off site, brought to site, and installed really quickly on site, maintaining high quality of the off-site production. And we'll see some examples on how they're manufactured and then how they translate in terms of environmental impact. In the last few years, the team and I worked on developing a few things, life cycle assessment and strategies to bring the company to zero. Curtain wall envelope systems are a big part of the overall embodied carbon and environmental footprint of the overall building. Accounts for 15 to up to 25% in certain cases. So it's really important to tackle the envelope early on and to try to find opportunity to decrease it as much as possible. Especially now with low carbon concrete or structures like mass timber, the impact of the curtain wall is rising compared to the other subsystems. So it's really important to focus and see what are the paths that we can take to reduce the impact. So in the past few years, we developed kind of a roadmap to get to zero, ideally by 2040. So we started building the baseline, right? So developing solid life cycle assessment across our product. We do custom, so we focus really on repeatability of our life cycle assessment that we can adapt and create super quickly on all different projects, so we know what we're actually installing. So once we have that baseline, right, we can start understanding, okay, what we can do, what action we can take to decrease our impact. So we're looking, of course, in factory emissions, acquiring low carbon aluminum, low carbon glass, low carbon mineral wool, right? So we're working with the suppliers to see and procure low carbon materials during the projects. So that's kind of the main focus that we plan to take in the next 5 years to reach 2030. With all this best practice in place, right? We estimated that we can get to 50 to 60% reduction of carbon footprint. The remaining 40s are the ones that are really hard to achieve. And in order to achieve that, we have to introduce, circular design for disassembly, take back programs. Otherwise, it's impossible to generate the same quantities of curtain wall without continuing emitting a certain amount. So it's crucial to bring back as much material as possible in terms of recycling or in terms of reuse of components across projects. So in the last few years, we've done many things. We generated the project-specific third-party verified EPDs for more than 10 projects across the world, including 2 in the US for the UC Berkeley Gateway project in California with Turner Construction. And in that project, we were able to track against the CLF baseline a reduction of around 15% of global warming potential, considering the design of this particular facade. And then we are starting implementing life cycle assessment and embodied carbon assessment across all our projects and tenders so that we can track how they evolve from the early stage down to the installation process. On the parallel track, we started monitoring scope 1, 2, and 3 carbon emissions according to the GHG protocol. And we recently submitted SBTi short-term commitment to 2030. So how is made and how we can take actions to achieve lower curtain wall systems. So we start with a lot of design, a lot of engineering, a lot of project management. Given that we do custom projects, every time is different, and it's a challenge, but at the same time is a big opportunity because we can optimize material shapes, work with our suppliers like Guardian, ROCKWOOL to have the best product and the minimum amount of material possible to achieve still the performance that are specified, but really optimizing the system. And that is really important. It is where a lot of opportunity lies. And we'll see some examples later. And then there is all the sourcing, the delivering of the materials in our production facilities. We take these semi-finished products and we start machining them, making them ready to be assembled. So assembly happens in an assembly line, really similar to a car assembly line. So we start assembling the framing, and then they pass to the next station where they add infill materials, like for example the glass, the insulation, goes on, add the silicone, and go to the next station where they add the finishes touches, and then once it's ready, it's all assembled. We have the grading process where we package them and load them to the truck. Most of the time it's trucks, sometimes are container ships for specific projects, and then is delivered to site where it's installed, picked up by floor cranes or tower crane and set on the building, as you can see in the last few images. So pretty standard project process. We get the materials from the different suppliers, and then we assemble them to make the finished product that you see on the building. So as I said before, right, we started working on life cycle assessment of our system a few years ago. We can tackle the entire life cycle of of our systems from A1 to D. Of course, we have most of the data from A1 to A5, so we focus on that. We can control and take actions on from the A1 to A5, but we can cover the entire spectrum of the life cycle assessment. So how we're doing life cycle assessment of our systems that are custom, right? We track every material that we have installed for our proprietary system that we map basically every single component. Each component carries a specific weight, and to each component we associate a specific product EPD if it's available. Otherwise, we created environmental profile modifying equivalent data set to match as close as possible what we're actually getting for that particular project. So based on that, we can assess the scope 1, we can assess the A1 stage, and then we're monitoring factory energy consumption, emissions, ancillary materials that goes into the production, like silicon, screws, timber, all these miscellaneous materials that goes into the production. We're tracking them to account properly of the A3 emissions. And then, of course, we know where the material is coming from, how we're going to transport it, how we're going to assemble in the factory, so we can cover all the A2, A4, and A5 emissions associated to the production of the product. So a few slides, just an example, right? This is like just a quite typical curtain wall panels that you see in many buildings in the last few years, right? You have a 5 feet wide unit, 15 feet tall, with a vision glazing and a shadow box at the top, some vertical aluminum fins and aluminum framing at the back. And you can see that here the number, it's around 325 kilos of CO2 per square meters. And most of it, right, 80% of it, it's on the A1 phase. The remaining, it's a small percentage. So we want to focus first on how we can reduce the A1, and then slowly focus on the remaining life cycle stages. And here you can see also the breakdown in terms of materials. The main contributors are aluminum, glazing. Aluminum, most of the time it's 50% of the pie, sometimes even more, 70%. So we're going to work mainly on how we can optimize glass and aluminum, both in terms of quantities, but also in terms of supply chain. So here are some facade optimization actions that we can take, and most of these actions happen during the design process, right? So it's really important to start early to investigate some of these options. Some of them, they're cost neutral. Most of them actually are cost neutral, and some are also cost savings for the project. So having that early interaction during the design process can carry really extreme benefits. Some of these actions, just going through quickly, you have the effect of the bay size, so the width and the height of the units, right? That we can achieve. For example, in this case, from 5 foot wide unit, we can go to the 7 feet wide unit. We can get a 10% reduction per square meter, and then shading things. We can optimize the system. Optimizing the extrusion thickness, the glass thickness based on actual performance requirements, based on the building orientation and action. So you can see that you can achieve up to 30% carbon savings. Once the system is optimized, we can go and optimize the materials, right? The supply chain. And you can see here some examples like low carbon aluminum, low carbon glass, to
Andrea,
achieve an additional 50%.
We might pause you just for a second. It is 1 p.m. And so just in case people have to jump to other meetings, we just wanted to, perfect. No, I can give you some time to wrap up if you want. And then we can go to a quick Q&A session, but just wanted to alert everyone.
It's just, So there are optimization from design engineering standpoint that are the first one that we can take, and then we can dive into further in the supply chain to achieve the rest, right? And when you have already optimized system, we can tweak and explore options to for low carbon material, optimize supply chain, assembly nearest, right? So we can have incremental savings across the process. Thank you so much.
Perfect. Thank you. Thank you to all who presented. This was very, very informative and a really great opportunity. I do know, like I said before, that there are people that probably have meetings, so please feel free to drop off. But we will still keep the recording going in case you want to come back and listen. So I think we have a little bit of time for Q&A. If all of our speakers are free for a few more minutes, then we can run through some quick pressing questions if you guys have any. So please feel free to just jump out.
Yeah, just to emphasize, I mean, so Alejandra just responded. There was a question just about, you know, our new facility that's going to be coming online in Eastern Washington State, which we're excited about. It won't be online until 2027, just so everyone knows that's kind of the target date. And it's all the ROCKWOOL's commitment, so all new factories will be fully electric cupolas. So that's part of our kind of mission and the goals that Alejandra kind of indicated. So that is on par, and we are looking to make that a hydroelectric facility. As far as specifying specifically out of that factory, it is a challenge based on just optimization of product lines and optimization of getting product to where it needs to go. And certain products can be manufactured in certain facilities, but might not be able to be manufactured in other facilities. So when we cross that bridge, I think it's going to be challenging to be able to specify specifically from a single factory. So you'll likely need to follow our standard, and we have product-specific EPDs that are across all factories. And I know Alejandra's worked on, if you need specific letters, I think even in the state of California for, I forget which compliance requirements it are, but we can kind of work to get the requirements out of a single factory. But I mean, at the end of the day, most of the product that we are manufacturing and sending to California will be coming from that facility. From a logistical operations perspective, like that's where we want that product to be going. But I don't think we'll be in a position to guarantee that we can get it there from that facility.
That's very good to know, because I think sometimes with other materials, like this gets talked about with steel, you know, like, are you getting it from a specific steel mill? And is that mill farther away than what you would have otherwise bought from? And are we just kind of shipping the same group of material, the same set of stuff to different places around the country because your project has an LCA and my project doesn't, or whatever? So kind of the feasibility and the effectiveness of those specification approaches, I think, are like really important to talk about. But it is great to hear about facilities
and I'll
going
also
electric.
emphasize, and by means I'm not trying to pivot. And I think embodied carbon, you know, we are very committed at ROCKWOOL to reduce that impact. But I think one of the value adds that I think Alejandra tried to emphasize is, you know, the whole picture of sustainability when it comes to circularity, and in California, in a lot of areas, when it comes to fire resiliency and when it comes to long-term performance and maintaining our value for the life of the building. There's a number of things that we as kind of design professionals, construction professionals need to kind of recognize as well. So, you know, we're trying to check lots of boxes on that side of it. And, you know, it's, you know, even with siding factories, you know, like historically, you know, the grids of the locations where, you know, we've sited factories over the last 85 years are not always the cleanest grid. So even if you move to electrification of the factory, it doesn't necessarily mean that the product will be cleaner per se. And I think that goes to probably with all production facilities that are out there. And so it makes it really important. And that's why ROCKWOOL has a commitment in terms of siting factories where the grid is supporting clean energy. And that's why we're, you know, super excited about Walla Walla. And we have another facility in Grand Forks, British Columbia, which is also an electric cupola that runs predominantly on wind power. So the West Coast is kind of helping knock it out of the park when it comes to our embodied carbon statement. But it's that's something we're continuing to work on.
Thanks, Todd. And it looks like maybe Catherine Young, if you're still online, was your question answered? Feel free to ask it.
You know, I don't know that it was, so I'll just ask. Alejandra, was it? was saying that some of the strategies on the slide about design bringing down embodied carbon were not really cost impacts, and I was just curious which ones those would be, specifically about the spandrel panels, if those are cost neutral.
Yeah, I think that in that particular case, we were exploring, switching from shadow box to spandrel glazing. So with a fritted glass or a float coat on the glass, right? You basically remove the need of an aluminum panel on the back of the system, so the appearance will change, right? But from a material saving standpoint, you're actually saving carbon and saving also a little bit of cost because of the switch between shadow box and spandrel glazing.
Okay. Yeah, thank you.
Andrea, have you found that architects are open to some of these changes that would reduce embodied carbon, but also kind of affect the aesthetic appearance of the system?
It's hard. It's not easy to change, especially when you have the impact on aesthetics. Those are the main ones that they're difficult to get through. Still work to do. But in a few projects that, for example, they were open to explore, low carbon glass, knowing that you cannot get low iron, low carbon glass, right? So I said, yeah, we know, we're open to explore to go to a mid iron low carbon glass. So it's going to be a slight impact from aesthetic point of view, but it's still worth exploring it. So I think that it's going to be gradual. It's going to come, but will take some work.
Thank you. Any other questions that we haven't touched on?
Yeah, Laura, there was a question from Alejandra about has the trade-off between embodied carbon savings and operational energy carbon savings been studied internally at Guardian between single, double, and triple? I was typing it and I thought it's easier maybe to answer it. I don't believe we have anything published. What we do have beyond kind of anecdotal and everything that we do is glass centric. So whether it's a solar heat gain coefficient or VLT, we're saying, hey, this is for the glass only. We don't consider the framing or anything out for various reasons, but the good reason being is kind of we're not in control of that, which is where we partner up with industry, peers, NGA, FGIA, GON, you name it. But we do actually have an energy calculator on our website. It's kind of a rudimentary tool to kind of say, hey, take this typical building, whether it's commercial or residential. This is the window to wall ratio, and you put in a bunch of parameters, including your glass buildup, and it'll actually kick back to you like assumed energy costs and CO2 emissions. Again, it's not going to be very project specific to your project, but at least it will let you compare different glass buildups and different coatings and on different elevations. So that is a useful tool, but again, with the caveat that it's a reference tool. We are, on top of that, we do partner up with other people, and this is a call out to anyone who's interested in doing this. So like with VIG, we're really interested in paybacks like that. So VIG is an interesting one because we're still as an industry kind of limited to sizes. So we've actually been doing some studies with others where they've been doing just that, especially at spandrels, and seeing, hey, is there a benefit to the end user to using VIG in certain locations only while we overcome all the other hurdles? So in answer to the question, no, but there are tools available to us to work with each other to get you those numbers for project specific criteria.
I would just say too, Kris, like it's a dynamic equation too when you talk about
Yes,
operating
yeah.
energy. And like it's a function of like where is your project located? How is the environment acting on it? What is the expectation of energy needed to heat or cool those buildings? What is the integration with products like insulation, and how airtight is your building to kind of help reduce that carbon side of it? Like if you look at things like Passive House that kind of optimize the envelope for the climate that it's in, you know, like even for me, like I'm not telling you you need to use tons of insulation. You need to use the insulation that's right for the building to operate effectively. So when it comes to triple pane or double pane, you know, that's going to be kind of hard to compare and contrast that payback. There's a lot of factors to go.
Exactly. Yeah. And that's why I'm excited also about like the enclosure commissioning stuff that's happening, is being able to use real projects, come back in 5, 10, 20 years and we can calibrate these numbers and say, hey, what was the actual payback? That's kind of exciting to me. But yeah, the tools that we have they're good reference points if you want to compare one build up to another, one coating to another. But yeah, as you say, countless parameters.
All right, thank you. And it looks like we have a question from Scott, and unfortunately, due to time, that will be our last question.
Yeah, for Todd and Alejandra's kind of just a clarifying question that it seems like once the Washington plant is online, that, you know, that it's awesome. It's going to have low carbon products, but it will really just kind of contribute to the ROCKWOOL North American average, and that, you know, like building and LCA practitioners might not be able to quantify that plant's product. Is that an accurate statement, or am I mischaracterizing that? Thanks.
Yeah, so at the moment, you know, we do have, as I'm sure you're familiar, a weighted average EPD for all of our production facilities in North America. You know, as policy kind of evolves and the needs kind of expands, you know, we're continuously looking to see how we can be continue to be more transparent with that. You know, we are always happy to have, you know, one-on-one discussions. If you know where the project's located, and, you know, if we kind of have a more concrete sense of where the product may be coming from, we could give you some more details in terms of, you know, plant specific details. But generally, because we cannot guarantee upfront that, you know, all projects in this region will be serviced by a certain facility, the weighted average approach is ultimately from a, you know, initial design phase going to be the most accurate, not the word, but it's going to be the most relevant one to use at that time. So we can certainly help with post of being more accurate, but from a planning perspective, the weighted average will kind of be best in class for rule of thumb calcs.
And Scott, we could also talk, you know, when the projects are on the front side, because we'll have a better sense of what products are coming from what facility. I mean, there's certain materials that we can only produce in certain factories for specific reasons. And so maybe the transparency happens on the design phase of, you know, what products are you guys planning to implement? And, you know, what is our confidence level of being able to get that product out of a specific facility? And that might be a good way to start.
Got it. Super helpful. Thanks, you two. Really exciting stuff.
Yeah, and just to kind of reiterate, like certainly like our roofing product that has specific facing on it needs to come from a factory that can apply that facing, and this factory might not have that, right? Or, you know, we have, you know, just that's kind of like, I guess, one example, but like those are the things that we can kind of chat with you about in advance.
Awesome. Well, thank you so much to everyone. I do think we are running kind of at the end of our hour here, but thank you so much to all of our presenters for coming and sharing all this very informative information. And thank you to all who joined. We will be posting this video on our YouTube page later this week. And then also stay tuned for our next event next month, which will be announced in the weeks to come. So thank you all.
Everyone.
Thanks, everyone.
Thanks,
Thank you.
everyone.